Well, I guess that's my sign. The music stopped. Must mean I have to start. I mean, it's only 6:58, but, you know. Okay, depends on the clock. This one says 6:58. Credit to all of you guys for coming today. I don't know how they pick the time slots for these things. When I saw it was 7 o'clock on Tuesday, I was like, really? This is the slot we get? But there's some random draw system, and I don't know how it works. The mere fact that you're all here after happy hour upstairs, I mean, I'm impressed. But I wish I had, a keg of beer to offer in the back, but, what can you do? There's Coke, if that really counts, I'm not sure. At any rate, bit of an introduction. My name is John Winford. I'm a program manager with, obviously, AWS. A bit of my background, I actually was involved in the launch of the database migration service way back at reInvent 3 years ago. That was when we announced it. The fact is it didn't actually go GA until March, as is the way these things go. So needless to say, I've been with the product for some time and have been involved in a lot of database migrations. I'm assuming, based on the title here, everyone's interested in learning about database migrations. I like to start things off with just a bit of a survey. Has anybody actually used DMS or SCT yet? All right, so we've got a few in the crowd. That's good. Hopefully everyone is actually interested in migrating, because we're going to spend an hour talking about it. But I promise you one thing, it's not going to be death by PowerPoint. I know that is a little boring, especially when you've probably been, this is maybe your 6th session today or something like that. You maybe had enough of them. I've got quite a long demo planned, so we're actually going to get so-called hands-on with the product, or at least I will be. And with that, you get the joy of watching me, and hopefully nothing goes wrong, because demos, that's just how it goes. But hopefully that will be of interest. But we're going to dive in and talk about, well, let's just start with what we are going to talk about. Bit of an agenda. We're going to say, okay, what's in it with the cloud? It's one thing to talk about a sales pitch. It's another thing to actually do it. How is it I can actually do a migration? And then with respect to the tools that we're talking about today, when should you use them? They're not always the right solution for your problem, so it's important to understand just when you should think about using our particular migration tools and when you should look at using something else. Now, I'm assuming everyone in the room is pretty technically inclined. You probably want to know how this thing works behind the covers. I'm going to dive into just a little bit of the depth as to how it works. Don't worry, there's going to be no Java code flashing up on the screen or anything. But we'll talk into how the migration process works, what are some of the technologies we use behind the scenes to actually make it happen. And of course, if you have more detailed questions at the end, feel free to fire them along. I'm actually expecting some of my team members from the actual development group to appear in here at some point. They're probably busy enjoying the beers themselves at the moment. As I said, big demo, that'll be coming up. And then a little bit of a talk about what some other customers have done with respect to database migrations. It's been out for a while, so we have some good examples. And then, of course, where can you go for more information? Where can you go for help? And really, how do you get started? All right, so as I said, kicking off with the cloud benefits. This isn't an RDS session, but I always like to start off with a bit of an overview of RDS in case anybody has not used it before. Migrating to the cloud, if you're going from on-premise, if you were to just go and do the basics, and by the basics I mean go and install database software on EC2 and run it there, you're already miles ahead of where you were. You don't have to go and procure your own hardware, install operating systems, that sort of thing. But if you really want to take things to the next level, you should have a look at RDS. RDS allows you to basically abstract yourself from a lot of the ongoing maintenance and operations type events that you would have to do with a database. To give you an idea, if you haven't looked at it before, instead of having to go and install your own database software, configure it, set up backups, do monitoring, that sort of thing, RDS does all of that with a click of a button. In fact, if I have a bit of time, well, actually, I'm probably not going to have quite enough time, but you can launch an RDS instance in literally, the mouse clicks take about 20 seconds, and the instance will be launched within 4 minutes. So if you think about how long it takes you to spin up a database instance, RDS definitely is faster. Amazon's pretty big about platform agnostic. As you can see across the bottom, RDS works with a range of engines, both open source and commercial. And of course, we have our own flavors of these engines as well with respect to the Amazon Aurora RDS platform. All right, that's enough of a RDS pitch, except I'll just tell about a little more details with respect to some of the things you can do on the cloud. as I said, lower total cost of ownership because we manage it. If you look at RDS, okay, my notes say it takes 6 minutes. I said 4. Whatever. It's pretty quick. You can do things like deploy multi-availability zones. So for those of you that don't know, a region at AWS consists of multiple availability zones. And at an abstract sense, you can think of an availability zone as a data center. So in any given region, we'll have multiple availability zones, and they'll be geographically dispersed around generally a major metropolitan area. They'll be quite far apart, such that if was something to ever happen to one of them, the other 2, 3, 4 will still be available. So when you deploy the multi-AZ option with RDS, what's happening behind the scenes is we're spinning up one copy of your database in one availability zone and another in another zone, such that if anything ever happens, you get automatic failover from one to another. So basically what it comes down to is it's DR with a single mouse click. Pretty neat stuff. You can do other things like spin up read replicas, obviously. You get backups, with a click of a mouse. And you get other neat things like if you decide to shard a database, well, you don't have to maintain those shards because RDS will do it all for you. All right, so the journey about database migration. How do we get here? So we have this neat product on the cloud. You can run your databases on EC2. You can run them on RDS. That all sounds very good. You probably know a bit of the history about AWS. A large number of our early adopters were startups. These startups found it easy to incubate their ideas on the cloud and scale up as needed. But what about existing enterprises? Enterprises that have been around for many years, have their own either data centers in-house or through a third party. How is it they can actually migrate to the cloud? Well, at AWS, we believe in being responsive to our customers. Customers have asked us to make these migrations easier and less intrusive. They want to be able to migrate with a minimal downtime and have the flexibility to go to any RDS engine type that they want. Once that migration is complete, people have asked us for ongoing synchronization. That is the ability to keep a source and a target in sync. They want to be able to do that sync not only between engines that are the same, but engines that are different, and possibly between on-premise and the cloud, or say 2 instances in the cloud. And it's this mobility that addresses one of the #1 requests that we have. That is the ability to migrate off commercial, license-intensive database engines onto cloud-native open source solutions. So we all know we're going to talk about DMS and SCT today, but pre-DMS, if you wanted to do those sorts of things, you didn't have a lot in the way of options. You could go out and buy costly license-intensive replication software. These things often came with 5-figure price tags. They weren't easy to set up, or they required the use of expert resources to do so. If you didn't want to do that, well, you had to have a long downtime to do your migration. It was really the only option out there. And then if you wanted to actually switch between engines, you needed to find somebody who knew all about one engine, all about the other, and could actually write the code to do the migration between the two. And that is update the schema of the engine, the triggers, the functions, the procedures. Needless to say, they're pretty hard things to do. So that brought us to DMS and SCT. We developed this service. We designed it to be simple. You can get started in less than 10 minutes. And we designed it to enable near zero downtime migration. Basically, we were looking to make a bit of a migration/replication Swiss Army knife to give you the ability to replicate between on-premise systems, RDS, EC2, and across database engine types. And you can see it's been pretty successful. We've migrated over 45,000 unique databases. That number keeps growing day by day, and people are pretty happy with it as it just keeps ramping up. Now, I mentioned this a little bit earlier. These products are not always your best answer. And that sounds funny. You'd think I'd be here pushing my own product. Well, when we get to the pricing slide later on, you'll see that DMS is not a money-making thing for AWS. It's an enabler. We want to make it easy for you to migrate to the cloud. We're not trying to make money off you while you're doing your migration. What that also means is you should look at other tools too. In particular, if you're not switching engines. So DMS's real strength is what we call a heterogeneous migration. That is switching between one engine and another. But if you're not switching engines, there might be a better way to do it. So SQL Server. Say you were going to RDS SQL Server. A couple months back, they introduced the ability to import a native back file. So that is, you can take a back file export from your SQL Server, put it in S3, and tell the RDS SQL Server engine to just go and ingest it. You're doing MySQL. Just think about doing a read replica. It's going to be a much easier, quicker way to go about it. And with the other engines, you've got some other options too. You can do a PG dump, PG import for Postgres. But again, it depends on what your exact requirements are. Not all of these options here give you ongoing replications. So what you can also do is merge some solutions. So say you wanted to do a SQL Server minimal downtime migration and stick with SQL Server. You could take that back file export to get your lump sum of data, so to speak, where it is up until now, and then use DMS just to replicate the changes that have happened during that time that it takes you to move the back file across and import it into RDS. So just have a consideration. Don't just jump in blindly and say, this is the solution. There might be a better way. But DMS, like I said, is very much the replication Swiss Army knife, and it will likely be involved in your plans in some way, shape, or form. So a bit more detail about when you should use DMS and SCT. 3 main scenarios. 1, modernize. You're looking to convert from one database engine to the other and update the associated application code using the code conversion features of SCT. So SCT can both convert your database schema and help convert your application code. The obvious answer is a migration. So as I said earlier, its primary focus is heterogeneous migrations. You can also use it for homogeneous migrations, but it may or may not be the best solution. Some other neat things people have done, you can see up on the screen there. People that have been with Amazon for a while know that the original networking infrastructure we launched with many years ago, we now refer to as Classic. A few years back, we launched what's called VPC. There's not a great way to move between the two networking infrastructures, but DMS can help. DMS actually can reach out to pretty much anywhere and pull in data as long as it can make a network connection. You'll see when we get into the demo a bit later. Basically, if you think of DMS as a query tool, as long as you can make a connection with your favorite query tool to your database, DMS can pull the data out. So it's really good in being able to move information between different networks and that sort of thing. Other people have used it to do minor version upgrades. So if we go back to RDS, RDS can handle minor version upgrades with a simple mouse click. You go, okay, change from, I don't know, 9.5 to 9.6. But to do that upgrade, it does take a small outage, right? It'll be down for 3-4 minutes as it reboots. For some people, that outage is just not viable. They can't handle it. So what ends up happening is you can spin up a new database with the newest version, whatever it is, and then use DMS to just replicate between the two and just take a very small outage for the amount of time it takes you to update a DNS record. So some neat use cases you can do with that. Replication, there's some systems that don't support cross-region read replicas, so DMS can help set that up. And the other big areas are things like data warehousing. So people will use it for ongoing replication to pull, say, financial reporting figures from their online transactional database into a data warehouse. There's some caveats with the read replicas and using DMS as a DR solution. DMS doesn't replicate full DDL, so it'll replicate changes to your table. You add a new column or something like that, it will replicate that. But it will not replicate changes to, say, a stored procedure that you make. So there's some limitations as to exactly when you want to use it, generally based along how frequently your schema changes. So a bit more detail. When to use DMS and SCT? Well, the big one is, of course, when you realize you can move between database engines and database platforms. I want to highlight it. You see some arrows on the screen here. The fact is, it's important to highlight, especially with the relational engines, that you can move data in both directions. So say you can go, as you can see on the screen, from Postgres to MySQL. You could just as easily go back from MySQL to Postgres. The key one that some of our competitors like to point out is like, oh, look, Amazon Aurora, it's some proprietary engine. AWS is going to lock you in. That's actually not the case. You can use DMS to migrate data right back out of Amazon Aurora into Oracle if you wanted to. Now, I can tell you from seeing the anonymous usage statistic reports that I get every day, that doesn't happen very often. And other neat things, we've got some hooks into things like S3 now. So you can basically pull data out of any system, put it into S3 in a text file format, and use it for all sorts of integration purposes. Sky's the limit when you think about putting your data into that format. And of course, you can also use it to modernize your data warehouse. So it gets a little bit different depending on the targets, but you can use a combination of DMS and SCT to migrate from any of those warehouses you see on the screen to Amazon Redshift. A little bit different, as I said, with the warehouses. We have this thing we call the SCT extractors. As data warehouses don't change as frequently as a database, these SCT extractors actually are more of a point-in-time dump from the database, and it'll upload it to S3 where it gets ingested automatically into Redshift. So it doesn't do a streaming transaction thing the way DMS does, but it will definitely help you move your databases along. The other thing I should mention, there's a session on Thursday where we're going to demo our latest feature release for SCT and DMS, that is the integration with Snowball. So for really large data sets, you can now use Snowball to dump your data to disk, or to the Snowball in essence locally in your data center, ship that via UPS or FedEx to AWS, but at the same time automatically we'll have set up a DMS stream to replicate any changes that have occurred on the database during transit. So once that Snowball makes it to the data center, it gets ingested in, and then we'll apply all of the changes that happened during that time using DMS to your target database. So that's pretty neat. And on top of that, it's not just for singular large databases. You could use it for an entire fleet of databases. So you could put 20 different databases on that Snowball and ship it, and away you go. So in summary, why would you use DMS and SCT? Brings a lot of advantages to the market and makes it easier for you to move to the cloud. As I mentioned, it's very cost effective. When we get to look at the price list, it runs on the order of a couple dollars a day. And one of the things that's changed recently is we now offer free DMS if your targets are Amazon Aurora, DynamoDB, or Redshift. So it becomes really, really effective when you look at that. Yeah?
On the free DMS, is it any instance size or any particular?
Yeah, it's not any instance size up to like the 4x larges, but it is both the T2s and the C4s, just not the very largest of ones. It's documented on our website. You think I could remember exactly the sizes off the top of my head, but most of them. Most of them. And actually that brings up a good point. T2 micros, that's the smallest instance size, are free for the first year. They always have been, but I highly recommend that if you're doing a production migration that you do not use a T2 micro, because it will just take a very, very long time. It's an interesting thing actually when you're deciding what replication instance size to use with DMS. We've done some testing, and we've actually found that if you use a bigger instance, which technically costs more money per hour, you'll finish so much faster than you will with the smaller instances that you'll actually save money. So there's a fine balancing act there. And as far as limits in size, that's something I should mention. There's no upper limit on how large a database you can move with DMS, especially now with Snowball. You know, sky is really the limit. But as far as what I mean by limit, as far as how much you would move over the wire, we kind of recommend about 5 terabytes as a top. There's nothing in the code that stops you. We've had people move 15 terabytes, but it really comes down to how long you're able to wait, what your internet bandwidth capacity is, and that sort of thing. So, how does it work? All right, the database migration process. As I mentioned earlier, we have both the schema conversion tool and the database migration service. These things are close cousins. They'll probably come even more closer as time progresses. But the general idea is you use SCT to move your schema first, and then you use DMS to move your data. Now, the example that we've got up on the screen is a heterogeneous migration. It's important to note that these tools can also help you in homogeneous migrations. SCT can copy a schema, so it can copy an Oracle schema to an Oracle schema. It may not be your best option, again, just to highlight, for homogeneous migrations. There might be other easier ways to go about it, but it does some neat stuff. If you use SCT and run a report on your Oracle database with the optimization flag, it will suggest to you, based on looking at the metadata of your Oracle database, whether or not you could downgrade to, say, a cheaper license. So it has some extra niceties in there. So again, copy your schema with SCT, then use DMS to move your data, flip over. So a bit more detail about SCT, what it does. It converts the database schema. It converts a data warehouse schema. It also converts application SQL. And this is something that people often miss. So you go and you convert your whole schema and you move your data across, but all of your apps are still probably coded to work with your original database engine. It's not going to get everything, but what it can do is it can scan your source code repository and search for embedded SQL statements and convert those from, say, PLSQL to PGPLSQL. It'll work, generally speaking, if your SQL statements are in plain text, as opposed to using some library to get input from the database, but it can really help with the automation. We've had some good feedback on that. The other thing it does is run an assessment report. So if you're just thinking about doing a migration, there's no need to make a commitment. SCT is a free tool. So you can download SCT and point it to your database, and it's literally read-only. It will read your database and look at it and go, well, you've got so many tables, so many procedures, so many functions. This is the percentage that I can automatically convert to, say, MySQL, or to Aurora MySQL, or to Postgres. And then you can make a decision based on the outcome as to which of the target database engines you might want to consider using. Now, you're going to want to balance other things in your decision-making criteria, of course. If your staff knows absolutely nothing about MySQL, but they happen to know something about Postgres, you're probably going to want to choose that, even if, say, MySQL had a better conversion rate. So, there's some things to think about there. But the neat thing is, it kind of gives you a starting point as to where you might want to go with your migrations. What does SCT actually look like? It looks like an integrated development environment. And if you haven't looked at this before, you might be a bit surprised, because AWS is a synonym for cloud software, right? This is a client-side tool. It's a complete anomaly out there. In fact, when we developed it, I hunted around to our UX groups at AWS, and I said, look, I need some feedback on our design of this thing. And they just went to me and went, huh? We don't even know what to do. They were all about giving us feedback on web consoles and that sort of thing. It's just not up their alley. But it made a lot of sense to have it as a client-side tool, because you're doing a lot of back and forths to generally an on-premise database, looking at all the metadata, the structure, and probably doing multiple iterations of it. So we just decided to use it as a client tool. It's available for 4 different operating systems, so take your pick as to which you want to use. And it now comes, it didn't have this at launch, but it now has what we call the extractors that I mentioned earlier to help dump data from data warehouses, as well as this most recent release that came out 10 days ago can, of course, talk to a Snowball device that you plug into your local network. So SCT is really growing up and has a fair few bells and whistles to it now. I'll get into showing how it works during the demo, but the general idea is the left side tree is your source database tree, the right side is your target, and then in the middle are the components that you're working on converting. So DMS, how does it work? So the diagram is, well, we've had it up for a couple years, but I still think it's the best way to demonstrate how it works. On the left, it says customer premise. On the right, it says AWS. You really just need to look at this as source and target. So remember how I mentioned we don't believe in vendor lock-in? You could easily be going from AWS back to customer premise here. Or you could be going from RDS to EC2 or vice versa. The only restriction on AWS is that you can't go from on-premise to on-premise. One end of the migration has to be somewhere in the AWS cloud. So you kick things off by starting a replication instance. Now, there's a question earlier on replication instance sizes. At the moment, DMS supports T2s and C4s. We just did a bit of analysis and figured those were the best instance sizes to target. That's probably going to change fairly soon, because as AWS launches new instance types, it makes sense for all the services to adopt the ones that are most applicable to them. But basically right now, we recommend T2s for dev test, C4s for production. And all these boxes they're actually EC2 instances that we manage for you, and we have replication software installed. You never log on to the box directly. You interact with it through the API, the CLI, or of course the AWS console. Once that box is up and running, you define your endpoints. So you should think of a replication server as essentially a big CPU that just processes migration data. So you can have as many different sources and targets defined as you want. You could be moving data from an Oracle database to a Postgres database at the same time you're moving information from, say, SQL Server to MySQL. It just moves data around any which way. So you can have many different endpoints defined. For this diagram, in essence, you just have 2, a source and a target. And then you define a task. So this task I haven't mentioned it before now, but DMS is what we call a logical replication product or a piece of software. What that means is we don't move things at the bit level. We don't just go and start reading all the blocks of your database and moving it across. We literally go select star from your table and move it across. And the advantages that that brings is that you don't have to move your whole database. You could move some tables, all tables, or even certain rows in tables or certain schemas. So it really allows you to filter out what it is you need to move, and that's why it becomes useful for data warehousing and ongoing replication tasks as well. So once you've defined what it is you want to move, you just sit back, relax, and watch DMS move the data across. And if you've enabled the option, it will keep it in sync from source to target. Now this is another key thing to mention. DMS does one-way synchronization. There's nothing stopping you from setting up a sync going back the other way, but you're going to get some very interesting behavior if you try it. I don't recommend it. We basically don't have conflict resolution built into the system, so it's a one-way sync. There's some exceptions there. If you were migrating from one group of tables to the same group of tables on your target and a completely separate set of tables going back the other direction, that would actually work fine. But just generally speaking, if you had some troubles with that and you called up support, they'd just go, whoa, what are you doing? Right? So that's at a high level how DMS works. Oh, and I forgot to mention, once things are in sync and you're happy with it, you've done your testing, you just sit back, flip your DNS entry to point to your new database, and off you go. So a little bit more detail. The load happens table by table. Because it's logical, it just kind of works through the task list and starts migrating the information across. It sets up the metadata required at the target. DMS will create the table for you, but it will only create the table with the same table name and the same columns and the same data types. It doesn't do all the other stuff like triggers, foreign key constraints, that sort of thing. That's why you actually want to use SCT to pre-create your table for you. DMS just kind of creates what it needs, and that's about it. Goes through, by default, moves, I believe it's 8 tables at a time. You can customize that however you please. And of course, you can set up multiple replication tasks. As things are going, you can pause it at any time. It'll reload, restart from where it left off if you want to resume. It, of course, also handles interruptions. It'll keep on trying to resume. If you've enabled the multi-AZ option for the DMS instance, it'll, of course, fail over if, for whatever reason, an availability zone goes down with AWS. How does this ongoing replication work? Well, ongoing replication has another name. That is change data capture. There's actually no real magic here. What happens behind the scenes, as I'm sure most people know in the room, is a database has a transaction log. Changes are written to the log. So all we are doing is using the native APIs of the database engine to read the changes that have happened in that log and replicate that across to the target. That is also why we don't support really old database engines, because really old database engines don't have these APIs, and we can't get the changes. Now, in order to enable this, there of course needs to be something done on the database. All that is enabling logging. So Oracle, turn on supplemental logging. Postgres, we need access to the wall log. But the neat thing about this sort of thing is we don't need an agent. There's no software needed on premise to use DMS. Well, what else can you do? Some neat things. It's not just about migration. This is consolidation, right? You can take information from 3 different databases or more, might as well say n databases, and consolidate it all into a single target. The common scenario in this case is MySQL shard consolidation. Anybody that's used MySQL for the years knows that it doesn't scale particularly well, and eventually you need to shard it. These days we have Aurora. Aurora scales amazingly well. So what we're having lots of people do is consolidate all their MySQL shards into a single Aurora instance. And not only that, they're saving money as part of the process because Aurora handles those loads really well. They can use a smaller instance size class on Aurora than they were even using for those MySQL shards. But the other scenario looking at this would be if you imagine the target's a data warehouse. So you're taking information from your finance system, your CRM system, and maybe some order inventory or something like that, and putting it all in a BI system for analysis. You can do the reverse. You've got some giant SAP system, and you want to put bits of information in other databases for microservices or something like that. You can pull the information out with DMS. Or, like I mentioned earlier, with DMS, you don't have to take it all. So you can take slices of your table, essentially applying where clauses to your filters. So you pull out sets of data. What's a pretty common scenario is people, when they're migrating, they realize they don't need all the historical data. So they maybe only grab the last 7 years of data as they need for financial purposes and leave everything else behind. A neat scenario I heard just the other day from the product manager out of Athena is he's had customers take MySQL backups and put those backup files on S3. And because they're basically text files, he uses that for archival purposes. And if they ever need to look at some historical data, they can use Athena to query the backup files directly on S3 to pull out the historical data at the cost of, I don't remember what Athena costs, but it's like hundredths of a cent per query. It's essentially nothing. And then they've used DMS just to filter out the new information and keep that in their live transactional database. So kind of a neat combination of what you can do with the services, thereby allowing you to run a much smaller database server. So just to reiterate, DMS can move your data from pretty much any source to any target, whether that's homogeneous, heterogeneous, or connecting into something like Amazon S3. And S3 can be used as both a source and a target. For a little bit more detail on how you can do migrations, we're trying to make it easy. There's lots of blogs out there you can read. There's also something we just released the other day. We're kind of calling it a cookbook, if you will. You'll see the link on our website. And in particular for Oracle to Postgres migrations, there is hundreds of pages of detail as to pretty much every scenario you can encounter during a migration and what are the best practices and how you can handle them and move forward. So that's been a fair bit of me talking. Just going to unlock my computer here and get into the demo. All right, so we'll do that and that. Oh, isn't technology great? There we go. Up and running. So the demo I want to do today is an interesting one. Some of you that have used Oracle in the past may have heard about SwingBench. SwingBench is a performance testing tool, load testing tool that gets used on Oracle. Can emulate thousands of users hitting your database. So what I'm going to use one of the demonstration schemas that come with that system. It's called the sales order entry schema. And I'm going to migrate it from Oracle to Aurora Postgres, migrate the data across, and once that data has been moved across, that's the full load step as we call it, I'm going to hit it with SwingBench and generate a high load of transactions and demonstrate to you that DMS can replicate those changes across from the source to the target. Other things I'm going to show during the demo, in addition to how to do the conversion, is I'm going to show some of the new features that we've released with respect to data validation to make sure that your migration actually will complete successfully and did complete successfully. So to kick things off, you can see I'm just here. I'm using an EC2 server that I have launched in US West. Again, you can be anywhere you want. It doesn't really matter. DMS is available in every region around the world today. And I'm just going to start off by showing you my source and target databases. So I'm just going to use a free query tool, DBeaver. Again, you're totally welcome to use whatever tools you want to read from your databases. I personally like DBeaver simply because, well, yeah, there's a new version, but I'll just ignore that. It works with all different database engines. So you can see here on the left I have set up connections to a range of databases. So we'll take a quick look at this Oracle database. As I mentioned, there is this SOE schema, sales order entry, and it has quite a range of tables. Wow, it's not too huge really, but you can go have a look at it and say if we check out the customer table, we'll read the information and you see there's a bunch of customers. Now, it's obviously just generated information. I don't think there's too many people with these exact names. I've never met anybody with the last name of Rudder before, but nonetheless, we'll get that migrated across to our Aurora target. Just to prove there's no funny business going on, if I look at my Aurora Postgres target, you can see in here I have, in essence, an empty database. Just some default schemas that get created when you launch Aurora. There's nothing there. So let's kick things off. As I mentioned, the schema conversion tool is the first step for any database migration. So it's free download available on our website. I'm just going to launch it. This version, of course, I'm running on Windows, but it works on Mac and Linux, no worries at all. If you do download it, the only thing to know is you need to install the JDBC driver for the database engines you're working with. The lawyers told us we couldn't distribute it because they weren't our drivers. So That's just the one little bit of technical stuff you need to do to get it running. So I'm going to kick things off. I'm going to do a new project. And what is it I'm going to do? Remember I mentioned SCT can handle both transactional database conversions as well as data warehouse conversions. So if I switch that tab there, you can see I now get my range of data warehouses. It has a green plum, what have you, to convert. But I'm going to do a database, and I'm going to go from Oracle. And as you can see, we can go from a range of engines to Aurora Postgres. I'm going to hit OK. So what it wants you to do is define your connections to the databases. So you guys are all going to laugh at this. It's super secure, but you know what? It's a demo database. I don't really care if you connect to it. And I'm going to connect to my database. You can see I've done it before. It's remembered some of the parameters, but it doesn't save your password for obvious reasons. Connect in. And I can connect to my Aurora instance on the other side. All right, so there's that screenshot you saw from earlier. So my target, as you can see, not much there. And my source, there's a fair bit of stuff. So I'm going to do an analysis on the SOE schema. Go here. And I'll just start things off by asking it to create a report. And this is that assessment report I mentioned earlier. So this one's going to be a bit of a cut down version because I've already told it that I'm going to Aurora Postgres. But normally there'd be a couple extra sections at the bottom saying, okay, this is what it would look like if you went to Aurora MySQL or MySQL. So let's give it a second here. There we go. Eventually. So it's looking through all the metadata on that schema, looking at every procedure, every table, figuring out how it's going to convert it. And here we have that assessment report. So it says what my source was, and that's Oracle 11G, obviously, and gives you a nice executive summary, which you could send off to whoever actually likes to read these things. It says what it's going to convert. And because we're going to Postgres, you can see we're actually going to have a pretty good conversion ratio. So our schema is looking pretty good. Our tables and constraints are good. A little bit rougher when you get down to the code objects. Oh, sorry about that. But overall, not too bad. So it's important to note that database migration is always a project. It's not just going to be click button. So there's going to be some manual work in here. But statistically speaking, based on the usage that we've seen, we find that if we look at this particular example, Oracle to Postgres, we get about 85% conversion ratio. All right, and then if you switch the action items, you can see it tells you all the things that it needs you to actually fix manually. So if we expand this out a little bit, you can see here's our tables. There's some issues with the views, but let's just go and click on that customer table we were using earlier. And you can see here, actually, hold on, let me change the view here. View, main view. All right, so here's the customer table. Let me just apply that to the target. Or no, I need to convert it. Sorry, my bad. Convert schema. Yes. All right, go back to that customer table. At the top, this is what the table looked like in Oracle. And at the bottom, here's what that same table looks like in Postgres. And I can do that for any table. Exactly how it converts, right? And same goes for the views, the triggers, procedures. Basically, you can go through each of the objects and see what it looked like on the source and what it's going to look like on the target. And the general idea is when you're happy with it, you can right-click and apply it to the database. I just want to highlight you can also save it as SQL. So if you don't want to apply it to your database, you can just dump it as an SQL file, which you can either edit and or apply manually at a later point in time. So I'm going to apply that target. And when I've applied that target, I just want to highlight a couple things. I will quickly go back to my query tool, although I could do it in SCT. Do a refresh here. And you'll see now I have my SOE schema on Aurora. But if I go in and look at this, you'll see two things. First off, everything's lowercase, because in Postgres, things by default are lowercase, Oracle, it's uppercase, so it's just one difference. And of course, if I look at this table here, the customer table, there's no data. So remember, step 1, SCT, convert your schema. Step 2, DMS, move your data. The other thing to highlight is this little thing that appeared here, AWS Oracle EXT. What this is an extension pack that we install on the target database. And all it is a library of functions to help map things that exist, in this case in Oracle, to things that maybe don't exist in Postgres. So trying to replicate some of the functionality. So if we look at it and go into, say, procedures, you can see we've got a whole range of procedures here that help replicate Oracle information. And what this does is it prevents us, when we're converting your schema from your source to your target, of having to rewrite the same thing again and again and again. And you can just, I don't know, pick an example, anything like, you can see we've got some 2 chars to handle some character mapping and that sort of stuff. All right, so now, just to show some other stuff, I've got some neat queries here. If we look at Oracle, let's just have a look at the kind of data that we're looking at moving. Go back to DBeaver and connect to my Oracle database. SOE. All right, let's read the data. Paste that in there. Change my schema. And run. So you can see we're looking about moving, a gig and a half of data, give or take. Okay. The other thing I need to do is drop my foreign keys. So as part of a migration, if you've got foreign key constraints, you're going to get some interesting behavior. You don't want that to break. If you're not moving things in exactly the right order, you'll get some errors with your migration. So I've just got this script that I've got off the internet. You can find it in similar things, a million different places. And I'm just going to go and run it against my Aurora Postgres target. Make sure I'm looking at the right thing. SOE schema. Go in, and what it does is I create a temporary table to hold these foreign keys and constraints so that if I need to recreate them later, I can. And as if I run this, run that here, off it goes. And if I do a refresh, you can see I have this dropped foreign keys table. And there's all the foreign keys that were dropped from my Postgres database that I can essentially execute every one of these statements in the table once the migration is completed to put them back on. All right? So just a bit of a precondition step you can do. Some database engines like MySQL, you can add a parameter to the connection string, which just disables them in general, but Postgres doesn't have that, so I need to do that manually. All right, so now, I mentioned that DMS and SCT have very tight integration. I can go and create the migration task inside DMS, but I can also do it straight from SCT. So I can just right-click here, and I go create DMS task. I have to give it a name, so let's just call this Tuesday night, just because that's what it is, which replication server I want to use, and it already found my endpoints, my Oracle source and my Aurora target, and I want to migrate the existing data, which is what we call full load, as in move the data as it stands now, but I also want to replicate the ongoing changes. And a few other options, don't really need to worry about it right now, and hit create. So as I do that, if I go here to AWS, to the console, I'm going to sign in, go to DMS, and you'll see if we go down to tasks, I have this task creating here. So it's automatically connected to my replication server and is creating the task for me. Once it's complete, we need to make a small edit to it. And this is always the fun bits with demos is, how do you kill time while things are happening? But it creates pretty quickly. If I hit a refresh now, there we go. Looks like it's ready. I'm going to actually go and modify it. And one of the reasons I'm going to modify it is because there's just one thing that we need to add to the system, and that is another transformation rule. So with a DMS task, I should actually show you guys exactly what it is. Your task specifies what it is you're moving. So I'm going to, as I said before, I am going to make sure logging is enabled. I think I showed that. And also enable data validation. I know I said I was going to show data validation to make sure things work properly. So turn that on. And what it says, this is what SCT created for me automatically. It's saying grab all the data from SCT, no matter what the table name is, and include it. So this is, I mentioned earlier, you can filter out certain records. This is where you would edit that and narrow it down if you wanted. It automatically adds some transformation rules. Again, like I said earlier, everything in Oracle is uppercase. So it transforms the schema from upper to lowercase, as well as the table from upper to lowercase. But I need to add one more little rule in there, and that is, I'm going to scroll down, for my columns on my SOE schema for all tables. Actually, you know what? I'll just leave it as a wildcard. It doesn't really matter, does it? For all tables, for all schemas, for all columns, I want to make it lowercase. And the reason it didn't do that is you don't need to worry about transforming your tables to lowercase unless you have a task that replicates changes, because we never touch the columns with an update statement otherwise. So that's why it's not in SCT by default. The other thing it's going to do is, let me make sure it's not going to start task and modify. I do not want to start it. Just going to hit OK. I'm probably going to get an interesting message here. All right, so it's modifying the task. I've got 13 minutes to go. I just want to highlight a new feature that we have out there now. As soon as the modifying is complete. There's two parts to data validation. So you want to know that things are going to work before you start a migration task, and you want to know that they work when you finish. So what we actually added in the last couple weeks is the ability to check all your data types before you kick off a migration. And that's what this assess option is here. Before that, it was possible that if a data type wasn't supported between source and target, you might not find out until you actually got to the point of hitting that data type. But now with DMS, you can optionally do a query on the database ahead of time and see what is supported and what is not. So now that it's been the task has been modified, I can run the assessment and check out all of the data types in the database to make sure they're going to work when going from Oracle to Postgres. So this takes a minute or so to run. But what it does is it just ensures that during a large migration, that you're not going to encounter problems, 10 hours into things. That's just not a good scenario. So this is some of the feedback that we got from customers that we built into the system to try to make the migration smoother. As I said, it does take about a minute or so to run, but it's a minute well spent later. Yeah, you have a question?
You mentioned 80-something%
Yep.
success rate
Yep.
for Oracle.
Mm-hmm.
What is it for SQL Server?
SQL Server, again, depends on your target, but it's sort of in the 75 range. It's not quite as good. But yeah, to Postgres. But what's interesting about it is we collect anonymous usage statistics, and we sort of see where it is that people are having trouble. And one thing that's quite neat about SCT is we have new releases, roughly speaking, every 4 weeks. So every 4 weeks, you're likely to get a higher conversion ratio than you did before. I'm not going to say you want to wait forever, because you're never going to hit 100%. It's just not realistic to ever expect it. But it has definitely been improving as time goes on. Yeah? Okay, so by default, it's set down to about 2 minutes, but you can actually expect it more in the neighborhood of 30 seconds. And what's interesting, depending on your system configuration, we see those changes flowing through within 5 seconds sometimes. But we'd say 2 minutes just for a safety bet, or a safety buffer, I should say. But what you'll see when I get to it in the demo is it's much, much faster than that. All right, let's just see if this thing is up to date. Go in here, go to assessment results. No, it really is still thinking. Yep.
Can I use on-prem Oracle through AWS Redshift with this tool?
Yeah, that's supported. Yes?
For replication, how are you doing log management?
Exactly, yes. We mine the logs through the native APIs that are available from the database engine itself. Yeah. Yeah. Yeah, it's all, I've got a slide on it in a little bit later. I don't want to tell you the wrong thing, but yeah, there's definitely versions that are supported. If you have SQL 2000, you're out of luck. But most of the newer ones, you should be all right. Yes?
We got mics here. I'll put one on each side, and that way we can hear the questions.
Sure.
And stuff better. If you guys can like pass it around for me, I can't.
I mean, can everyone hear the questions, or do you want a mic? Yeah?
They're recording.
Mic? Oh, okay. Good point. Good point.
Oh, sorry. Quick question. Just want to know why the source, because we found that the source does not have Redshift. How come you cannot use Redshift as a source?
That's where SCT comes in. So again, when you're talking warehouses, you need to use the schema conversion tool to do the migration. But if you're going from a relational database, you can use Redshift as a target. Sorry, did you ask Redshift as a source?
Right.
No, these products don't support Redshift as a source, but Redshift has its own methods of dumping data out.
Oh.
It's Redshift as a target
Right.
for
That's
DNS
what
and
I found.
SCT.
Yeah, can
Yeah.
only be a target, cannot be a source.
Yes, correct. For Redshift, Redshift's a bit of an asterisk on there, if you will. But all of the other engines like Oracle, SQL Server, MySQL, they're all source and target. Yes?
Is there any limit on how long you should be doing the DNS replication or anything?
Nope, none whatsoever. In fact, we encourage ongoing replication as long as you have enabled multiple availability zone. Now, there's a few more questions, but I see the report has finished. We'll have time for some more questions at the end. I just want to make sure we get through the demo. So you can see now the report's finished. If I hit open, you can see which data types are supported and which are not. Now, what's interesting, this is version 1 of this feature. It was only released about 10 days back. It looks at the entire schema on the database as opposed to just the schema we're looking at. So if you look at these unsupported data types, you'll see they're all in the system schema. So what that means is it's going to work fine from a data type point of view. Okay? So now that the report's run, I'm going to actually kick it off. All right, so task is selected. I'm going to go and hit start. So the task gets running, and if we give it a second or two and we look at the table statistics tab, scroll up a little bit. It's never as fast as you want it to be during a demo. We should see this appearing pretty quickly. It still says starting. There we go. So you can see, I'm going to make this a little bit bigger for you guys. I wish I had better resolution to share, but here we have all of the tables migrating across. It knows how many rows we're going to migrate, and it also tells you how many records we're going to validate. So you remember when I went and modified that task, I turned on the checkbox that says Enable Validation. So because I did that, you see these pending records to validate here. What you also see are the inserts, deletes, and updates. Those are going to all stay at 0 for the moment. But what that is for the change data capture component of a migration, you'll see how many of these statements have been run, reflecting changes that have happened on the database. So as this runs, I should be able to, it's probably already moved most of the data in all honesty. It's pretty quick, yeah. So you see I just did a refresh there. So you can see now that we've actually already moved some data and validated some. So this last column here was pending records left to validate. So you can see we've validated all 1,000 records. It doesn't validate records where there's no primary key. So at the moment, our data validation is dependent on you having a primary key on your table. So you see it won't do those. But if I just leave that alone for a minute, and I flip back to the database query tool, what we'll probably find, if I read the data, you can see there we have our data in Aurora Postgres. So it's the same customer table from Oracle has been migrated across to Aurora Postgres. Now the last little bit of the demo I want to do is kick off SwingBench to show that a load will happen on the system. So just do a refresh here. We should probably see most everything's moved across. Yeah, you can see here we've got our million rows of order items and 700-odd thousand of orders. Everything's gone across. So I'm going to kick off SwingBench to actually generate load to show you that the CDC component of it works. That is the change data capture. So to kick off SwingBench, I just need to go to my desktop and launch the tool. So again, SwingBench, a free tool written by an Oracle developer, ironically enough. And I can go here and generate load on my Oracle system. Just make sure I can still connect to it. There we go. And I'm going to make some performance changes, if you will. So I'm going to say, let's put, I don't know, 4 users on the system at once. It's going to create a fair bit of load. You can split up the ratio based on which of the tables you want it to hit. But I'm going to keep it pretty simple for the sake of the demo and just kick that off here. And we should see these graphs going, and there you can see it. We're getting, you know, a couple hundred transactions per minute or transactions per second, depends which ratio you want to look at. And then what we'll see if I go back to DMS, if I do a refresh on this, table, you can see now I've got inserts, updates happening. So DMS replicates these changes across. And to your earlier question about latency, well, that wasn't 30 seconds or 2 minutes. That's just the CAN line I like to use. It replicates almost instantly, again, depending on the load of your database and the bandwidth and your connectivity, right? So there we have it. DMS has migrated information across for a bulk load and is replicating changes. So I'm just going to switch back now to the PowerPoint. Look at that. Yeah, so DDL, DMS replicates some DDL. To get into exactly which statements, again, look at our documentation, but basically what it replicates is DDL changes to the table. So if you add a new column or you add a new table, that'll get replicated across. But if you were to, say, make a change to a trigger on the table, that doesn't, at present, get replicated across. It's something we're looking at. All right, so we did the demo. What have other customers done? Look, we all see these slides. I'm not going to go into great detail. Needless to say, we've had a lot of people with a lot of success doing database migration. There's some names you probably recognize up there on the board. They've done all sorts of variety of things, whether it's minor version upgrades through to migrations from Oracle to open source, or possibly things like data warehouses. So lots of interesting stuff there. I did mention that I was going to talk about other things you can do with DMS. Here's some good examples. You can do classic VPC, I said that earlier, and analytics in the cloud is another really big one. So it's also good to highlight cheap read replicas. DMS, very inexpensive service. Unless you go and fire up the biggest of biggest instances, it's dollars a day. It's very, very inexpensive. And in fact, in about 2 slides from now, we're going to see the prices. Supported databases, quite a range. Some of them are definitely more popular than others. There's a question on which versions of SQL Server are supported. That's right up there on the screen. As well as it varies a little bit based on whether it's an EC2 on-premise or RDS instance. All this information is on our website and gets updated frequently. Sources and targets vary slightly. So that was sources we saw earlier. The variation is because some of those older database engines don't have an ability for us to read from the transaction log. That's the only reason there's the difference. Although in reality, I can't imagine you would migrate to an older version just because we support it as a target, but you know, it's there anyways. Pricing. Again, our website is the best place to go for this. This is just an example of the pricing in US East. You can see it's pretty minimal. Only if you get to the really big instances are you even getting into the dollars per hour. So we really like to say you can migrate a terabyte for $5 or so, and that's the case. Like I mentioned earlier, free DMS is something that we launched fairly recently. If your target is an Aurora Engine, Dynamo, or why am I blanking out? Redshift, it's free, right? So no worries there with your migrations. Resources available. Okay, I'm here, but I disappear fairly quickly. So where can you go for help after this? Obviously, our website. This is right on the console. You can see there are links here to documentation, getting started, and that sort of thing. Always read the manual. Sounds obvious, but many people don't. A lot of the questions that you will ask are there. Features and benefits, that's just some fun marketing stuff. Pricing, how much is it really going to cost? Support. I always want to highlight the support forums. Every service at AWS is different. Our service, we actually use our forums. And if you post a question there, there's a good chance a database engineer from the service team is going to answer it. So that's a little back door into getting quick responses on any problems you may have. You want to do things programmatically? You can always do more programmatically with services at Amazon than you can through the console. More features are available there, so if you want to automate it, replicate hundreds of databases that are essentially the same, I recommend you script it out using the SDK. SCT, very much the same thing. There's a user guide. You can download the files. As I said, it is totally free to use SCT. And of course, we have a forum as well for SCT. So the two products are related, but they do have two separate forums. Definitely go there for information. And if you need help, there are partners that can help you with your migration. They have all done Mini and can use our products and, as I said, any other tool in the toolbox that you may want to use to migrate. We don't really mind which products you use. We just want you to migrate to the cloud. So these guys are the ones to help you with it. And with that, I have 1 second left, and we're at the point of questions. So that's pretty good timing. Yes. And actually, I was told we need the microphone because it's being recorded.
I have the microphone, so maybe I can.
There you go.
Yeah. So DMS uses JDBC underneath.
Yeah.
So what would you say about the performance of our migrating large-scale database? And then, so what should I use? What size of database should I use using JDBC? And then where should I move over to
Using the SCT client with Snowball?
Yeah, Snowball.
Right. So there's no upper limit on the size you can use with DMS. We've had people successfully move up to 15 terabytes. 5 terabytes is kind of our recommended rule of thumb. You probably don't want to go much larger than that, I should say. But it really comes down to your exact scenarios, what sort of bandwidth you have available, and also how your data is structured. I didn't mention that earlier. If your database has like one giant table with thousands of lobs in it, you might have some issues moving that over the wire. Anybody who originally thought it was a great idea to put videos inside a database, just I don't know why. But some of those things can limit how big you are really able to move over the wire with DMS.
But for a 5 terabyte, is it what the performance numbers would be? Is it?
It varies so much based on your environment, your infrastructure, how hot your database is. It's our rule of thumb. We don't actually have anything on paper on our website because it varies so much. But we kind of say a terabyte every 12 hours or so. That's a rough rule of thumb. Who gets microphone next? Yeah, I don't know.
Does the replication include updates and deletes?
Yeah, it does. Yes.
Can you auto-scale the instances there?
So DMS instance, you can definitely scale it up, but you have to do it manually. So you'll have to go in there and modify the instance and increase the size. It doesn't do it automatically on the fly based on load.
And then,
Yeah, of course you can script it.
how does it charge the change data capture then? Does it make sense to have a larger instance when you're loading the initial load, and then for change data capture you have to manually change?
Yeah, I know I mentioned earlier that T2s are dev test and C4 are production migrations. Actually, what we find a lot of is people are using the T2s for ongoing replication tasks just because the load is not as big. Yeah, there's no point in having a C4 extra large for replication.
But per hour actually works on the task execution.
Sorry, what was that?
So the per hour sort of charges that you have is only charges when the task is running.
No, the hourly charges for DMS are while the instance is running. So definitely when you're done your migration, turn the thing off.
Okay.
Yeah. All right. Yeah, definitely. DMS is really region agnostic. You can pull data from US East and insert it into Narita if you want to. Yeah, but you remember I mentioned you don't want to go bidirectional because then you start getting some weird behavior. Yeah, no worries.
Do DMS also figure out automatically schema? I mean, does SCT mandatory steps?
So if you don't use SCT for your schema, DMS will create tables for you on your target that it needs to do a migration, but it's just going to create the basic table. It's not going to do any triggers or foreign keys. It's not going to do procedures, but it will create the table for you.
One more question. So during replications, what it uses? Is it use JDBC or ODBC or some other?
It's always using JDBC to, well, during the replication, it's actually using the API for the source database engine and getting the information out that way.
All sources?
For all of the sources we support, yeah.
I mean, whatever we support.
Yeah, I mean, there's some limitations on there. Like today, we don't support ongoing replication if RDS SQL Server is a source, but these are things that change as we develop new capabilities.
Even for Redshift also?
No, so Redshift's not a source.
Yeah, Redshift as a target.
Yeah, Redshift is a target. Yeah, you bet. If you're reading from an Oracle database feeding into Redshift, we'll replicate those changes across.
What I heard that Redshift, if you use JDBC and data ingestion in Redshift is performance-wise very slow if you use through S3.
Yeah, so I mean, some of the things we're beholden to the target database engine and what it supports. Behind the scenes with Redshift as a target, we actually do use S3. So we'll extract information out from whatever the source database engine is. We'll create files, we put in your S3 bucket, and then we call the Redshift copy command to ingest the information in. It's definitely not as performant as if you're using a relational database as a target. Were there more? Yeah?
So for Redshift, does it automatically also create sort key, disk keys?
Yeah, actually, that's a good point. I didn't mention that purely due to time constraints. But with Redshift, we actually analyze, especially in the data warehouse space, we analyze your usage of it, if you will, using the various metadata components that are there, and we create, excuse me, sort and distribution keys automatically in the Redshift target. And on top of that, if you already have a Redshift instance, we can optimize that Redshift instance. So you can point SCT at an existing Redshift instance, and we'll recommend optimized distribution and sort keys. And there's some dials you can twirl inside SCT to sort of indicate some of your preferences, if you will, during that process.
Oh, like column compression and other things I can do.
Yeah, so yeah, we definitely support some of that. Anything else? Yes?
Start replication after a long period of time. What kind of overhead is incurred to compare where you left off to?
So again, the replication is one way, so it's not so much of a compare, but as long as the log information is still available in the source, we're just going to read through. Yeah, exactly.
Is there any special privilege required? Is there any special privilege required users to?
Sorry, is there any what?
Special privilege required?
Yeah, so for every database, if you look in our documentation, we specify the exact permissions that are required. Obviously, you can't feed a replication stream if you just have very, very basic read permissions. But you don't need complete super user either.
Yeah, on top of the database privilege, you need other privilege. Like
Yeah, I mean, there's, again, as I said, every database engine has different permissions and privileges required. It's all documented. Other things that are documented are, if you're going to do ongoing replication, we specify how it is you need to configure a database, how you enable the transaction logging so that DMS can read the information out.
So is there any tool in place? Just now, user asked whether at what point are you suggesting using Snowball? Like, is there any tool in place to, like, you can install something on an existing database, then maybe collect a few days information and recommend, okay, this is the point that maybe we recommend if you should use Snowball or not to migrate?
No, there's nothing that sort of says when you should use Snowball versus not. I mean,
Yeah, like the lower end, let's say, 2 terabytes plus some type of activity. So
yeah, no, we don't have that yet. As I said, we don't actually have any real limits because it varies really on your architecture. And I understand what you're saying. Can we poll and then give a recommendation from there? At present, all I have is those rules of thumb to offer you, knowing that we have had people move up to 15 terabytes over the wire. Frankly, for the price of Snowball and the time it takes to ship the data, you really want to make sure you balance that correctly before you go down that path.
yeah, and it's the downtime.
Yeah, of course, of course.
I have a question on the scaling.
Yeah.
So if you decided to bump up the instance, do you need to stop it and start it, or can you do it like?
Yeah, no, it does take an outage, if you will. So you've got transactions going. They'll pause and you'll have to resume once it upscales.
Yeah, but is it mature, like it knows like where it stops?
Yeah. The information, the metadata, if you will, like behind the scenes, DMS keeps track of where it's at in a collection of tables. So when it starts up again, it knows where it left off. Sorry, is there a what?
Sorry. Is there a limitation of, let's say the source has 300 columns to move? Is there a limitation on the column number?
I don't think so, but actually, Ilya, do you know? All right, I think that's it. So thank you very much, everyone. Appreciate you coming, especially after beer o'clock.